Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this tutorial we will learn the remote procedure invocation RPI design pattern for microservices. I'll explain what is remote procedure invocation design pattern, where to use it, what are the advantages of this design pattern. I will also give you the real world example of this design pattern. So stay tuned and watch this tutorial till end. It is going to be very exciting and informative tutorial. There is a lot of learning involved in this video. Right friends? Friends, in the previous video, I discussed about synchronous messaging design pattern. Do you know what is synchronous messaging design pattern all about? Can you explain the synchronous messaging design pattern? If you know the answer, so provide your answer in the comment section of this video. If you have not seen the previous video, so please go and watch the previous video. The link is provided on your screen and also given in the description section of this video. For more information, go and watch the previous video on Code One Digest channel. Friends, so here is the agenda of this video. I'll give you the introduction of a remote procedure invocation design pattern. Then we'll see what are different types of remote procedure calls. What are the important components of remote procedure calls. Then we'll understand the working of RPC calls. Then I'll show you the real world example of remote procedure invocation. Then we'll see where to use remote procedure invocation design pattern. Then we'll understand the benefits of remote procedure invocation design pattern. And at the end, I'll be summarizing what we learn in this tutorial. Right, friends? So stay tuned. It is going to be very exciting and very informative tutorial. So do watch this tutorial till end. Right, friends? Okay, friends. So now let's start with remote procedure invocation design pattern for microservices. This is a type of communication design pattern. This design pattern is for the inter-service communication. And by the end of this tutorial, you will learn what is remote procedure call, how microservices can communicate with each other using RPI pattern. Right, friends? So microservices often communicate with multiple microservices in order to complete the complex functionality. Therefore, we can use inter-process communication protocol for microservice communication. The solution is to leverage the remote procedure invocation for any inter-service communication and collaboration. In this solution, the client uses request reply based protocol to make requests to the service. The well-known RPI technologies include REST, gRPC, and Apache Thrift. This pattern is easy to implement and there is no need for any intermediate broker for the communication. Service uses RPI for inter-process communication to collaborate and to serve the request. Client and servers are stubbed so that remote procedure call would seems like local procedure calls. Instead of accessing the remote services by sending and receiving the message, a client invokes the service by making a local procedure call. The local procedure hides the detail and complexity of network communications. Remote procedure call is an inter-process communication technique used to construct distributed and client-server applications. It is also known as a subroutine call or a function call. Today, gRPC by Google and Square represents an incremental step in the progress of scaling RPC for the cloud solutions. We use remote procedure call when there are multiple independent applications wants to share data or orchestrate cross-application processes. We often use this pattern to build a solution based on service-oriented architecture. It has become increasingly important for software architects to understand the mechanics behind the remote procedure call, particularly its role in the distributed architecture. Though they are flip side of this pattern as well, like services are tightly coupled with each other using this pattern. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you. Okay friends, so now let's understand what all different types of RPC calls exist. So there are primarily three different types of RPC calls. First is callback RPC. This type enables a process to process paradigm between processes and helps a process to act both as a client and server service. In simple terms, this enables any process to act as a client or a server. Now next is broadcast RPC. This type broadcasts a client request onto a network that is then processed by all the servers. So you broadcast all the requests to all the servers and let them process it. And the third is batch mode RPC. This type helps in queuing and separating the RPC request in the transition buffer on a client side. It sends the request to server in batches. Right, friends? Now let's understand some key components of remote procedure call. So primarily there are 5 components in any RPC communication. The first is client, then we have client stub, then next is RPC runtime or we say RPC protocol, and the fourth is server stub, and fifth is server. As you can see in the diagram that client prepares a message, pass it on to the client stub. Client stubs now use the RPC protocol to send the request to the server. On receiving end, the server receives the request from the RPC protocol and the server processes the request and sends the response back in the same fashion. Right, friends? So remember, there are 5 key components in any RPC communication: client, client stub, RPC protocol, server stub, and server. So now let's understand the tech stack of gRPC and working of RPC, how the RPC works, what are the internal tech stack for gRPC. So if you see a diagram on your screen, at the core it is based on TCP. You have a transport layer protocol. All RPC communication is based on transport layer protocol, that is TCP. And on top of that we use secure TCP, that is TLS layer. So all our RPC communication is based on TLS. That makes your TCP secure. So RPC runs on top of TCP, which means that it solves the problem of connecting connection management and reliably transmitting the request and reply message of arbitrary size. Then RPC actually runs on top of secure version of TCP, that is TLS. That means it also solves the problem of responsibility of securing the communication channel. And if we go next level, the RPC actually runs on top of HTTP2 protocol, which is itself layered on top of TCP and TLS, meaning RPC also solve 2 other problems, that is efficiently encoding and compressing the binary data into a message, and second is multiplexing the multiple remote procedure calls into single TCP connection. It makes use of binary data rather than just text, which makes the communication much more compact and more efficient, right? So this is the tech stack of gRPC. That is why the gRPC is very safe and secure and even faster. If you see the diagram on your left hand side, it will explain you the working of RPC, how RPC works. A client has a request message that the RPC translates and sends to the server. This request may be a procedure or a function call to a remote server. When server receives the request, it sends the required response back to the client. The client is blocked while the server sends the response and only resume execution after receiving the response. Now let's see a sequence of event, how it happens. The client stub is called by the client. The client stub makes a system call to send the message to the server and puts the parameters in the message. The message is sent from client to the server by client operating system. The message is passed to the server stub by server operating system. The parameters are removed from the message by server stub, and then the server procedure is called by the server stub. Right? So this is a very basic working of RPC, and everybody should know, should understand how RPC works and what are the role of stubs. So the very basic question comes to our mind: what is stub in RPC? So let's understand stub. The machine making the procedure call is termed as client, and the machine executing the called procedure is called the server. For every procedure being called, there should be a code which suggests machine that has to be contacted for the procedure. Such kind of code is called as stub. From the client side, for every procedure, there we would need a unique stub. However, the stub on the server side can be more general and only one stub is needed for handling the more than one procedure. Now let's understand RPC pattern with an example. RPC was used earlier to access the remote files and databases. The Sun network file system has implemented using the Sun XDR RPC system. RPC was running over Ethernet and was used to access the files on mini computers and mainframe systems. Now, if you see a diagram on your screen, RPC is especially well suited for the client server, that is, query response interaction, in which the flow of the control is alternate between the caller and the callee. Conceptually, the client and server do not execute at the same time. Instead, the thread of execution jumps from the caller to the callee and then back again. So if you see the diagram on your screen, the caller is making a remote procedure call by sending a request message, contains the remote procedure parameters. Now server receives that request and start procedure execution. The procedure executes and sends the response back to the caller. Till the response comes to the caller was waiting for the reply. And once the response received at the caller end, then it resumes the execution, right? So that is how RPC works. And we have seen that it was used to access remote files and databases in the past. Now let's understand some of the use cases of this design pattern, where and when to use this design pattern. So use this pattern when the multiple independent application wants to share data. Use this pattern when multiple independent application wants to orchestrate cross application processes. Use this pattern when you want to have a simple architecture. Use this pattern when you don't want to have intermediate broker for communication. Use this pattern when you want to make call to remote service like a local procedure call. Now let's understand some of the advantages and disadvantages of this design pattern. This pattern is very simple and use a familiar technology. It is based on request reply and it is easy to manage. It has simple architecture as there is no need of intermediate broker. Despite of all these advantages, there are major drawbacks of remote procedure invocation design pattern. Like it only supports the request reply based communication and not any other interaction pattern such as notification or request async response, PubSub model, etc. It creates very tight coupling between the services. This requires the client and service must be available for the duration of interaction and client needs to discover the location of service instances. RPC is a blocking call. When you call a service, you have to wait until the response comes back. This is highly vulnerable to the failure due to communication systems, and there is no standard defined as of today for the RPC implementation. Okay, friends, so now let me summarize what we learned in this video. I gave you the introduction of remote procedure invocation design pattern. Then I explained you what all different types of RPC calls exist, what are the key components of RPC call that we should know. Then I explained you the working of remote procedure calls, how it works, what is the sequence of events. Then I explained you the remote procedure call with an example. We understood that how the Sun microsystem have used RPC call to access remote files and databases. Then I explained you the usage of RPC calls, when and where to use RPC calls. I also explained you the advantages and disadvantages of RPC calls, right? So friends, let me know if you have already used this design pattern in any of your project or seen a scenario where this pattern can be useful. Provide your answer in the comment section of this video. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.